AI doesn't have memory. And if we give it one, that's when everything changes. Today, I'm diving into the biggest challenge in AI, continual learning, and a new Google research idea called nested learning that could unlock the next wave of intelligence or introduce a whole new set of risks. Let's get stuck into it. Amnesia caused by trauma works a little like this. Everything before the date of the incident is intact, but after that point, no new memories stick. The person doesn't lose their personality, skills, training, or intelligence, but you may need to introduce yourself again and explain the context of how you became friends and how you met. Cognitive decline in older people is a little different. Memory fades bit by bit, often taking parts of their identity with it. But it's all to do with the way us humans work. Movies use amnesia as a plot device all the time. Born Identity, The Long Kiss Goodnight, Overboard, 50 First Dates, Memento. In 50 First Dates, Drew Barrymore wakes up every day with a blank slate. Does it sound familiar? Isn't this exactly how we treat large language models? Multiple chats, re explaining context. The more detail you give, the better the response. Google's new paper describes a new direction for continual learning. At the same time, experts like Ilya Sutskever and Jan LeCun are openly saying that the current way we train large language models will never get us to true AGI. Right now, big models like Gemini, ChatGPT, and Claude work around their memory limitations using behind the scenes summaries, little memory files, and store user preferences and a high level recap of past chats. Or things like RAG, which basically has this big database that you can insert current events, but you basically insert it into the large language model. The large language model take this information and wrap it around your next prompt. If you ask ChatGPT, how do I write a nice email? Your hidden meta prompt might say, Michael is head of sales at SSW, an Australian enterprise consultancy. He prefers Australian English, succinct style, and then the prompt. Most people don't realize this is happening behind the scenes. Claude leaned heavily into software context. Coding requires highly specific technical information. So Claude writes an internal project file describing all relevant code so the model can read it before generating new code. It's a clever workaround, but the principle is the same. The large language models are amnesiacs and they need briefing notes every time. Current deep learning models can only learn during training. Once deployed, they stop learning because updating the weights directly causes a thing they call catastrophic forgetting. New learning overwrites old abilities. If you're Google or OpenAI and you've spent tens or hundreds of millions of dollars training a model, you don't want it to degrade itself every time a user teaches it something new. Humans don't have this issue. Our brain consolidates new memories without erasing old ones. And we do it in a number of ways. Like sometimes we remember things straight away, and sometimes we sleep on it and we have a new skill when we wake up in the morning. The nested learning paper from Google argues AI needs something more like this. Nested learning works like Russian dolls. The inner doll is a fast learner, picks up short term info. The middle doll, slower learner, consolidates stable patterns. And the outer doll, very slow learner, stores long term knowledge. You don't rewrite the big doll every time something small changes. You update the small one and gradually let stable patterns flow outward. It's pretty clever, but very complicated. You need multiple optimizers, schedulers, safety checks, a ton of mathematics. And if the model starts learning from users, the risks grow quickly. As the authors admit, it's not magic. And they'll solve one problem and they may introduce others. One of the great minds in AI, Ilya Sutskever, recently said that scaling alone won't get us further. He made a few strong points from a recent video. The models look smart but make baffling mistakes. They ace benchmarks but fail on simple tasks. They can fix a bug and introduce a new one immediately after. It's like a uni student who gets 100% on an exam but forgets where the car is parked, can't get home. Ilya believes models are too narrow, too literal, lacking broad situational awareness. He says pre training is like living your whole life watching TV and reading books. Reinforcement learning is like humans designing a weird, tiny curriculum and hoping it teaches judgment. He believes this combo won't get us to true intelligence. My take on this is that the researchers aren't software engineers. This stuff isn't programmed, it's grown. The best researchers are trying to map AI onto the human brain. When the DeepMind team published Attention is All You Need in 2017, it unlocked modern AI because they were modeling biological attention. The next unlock, memory and continual learning, is now stumping the brightest minds in the world again. And there's going to be another breakthrough, supposedly. And it's not just Ilya. Many top researchers believe AGI requires solving memory and continual learning. But there's a problem. Today's large language models hallucinate, flatter the user, and can behave deceptively. Alignment is already difficult. Now imagine a model that learns from every user it interacts with. Today, reinforcement learning is supervised by safety teams. When a model ships, its behavior is mostly predictable. But if a model constantly learns and remembers, its behavior will drift and drift fast. Right now, if you correct an LLM, say, hey, you got this wrong, it doesn't learn. At best, the feedback is logged and maybe used for the next version. A future continual learning AI would learn and improve and change and scale up that learning across billions of interactions. Once AI can remember and improve itself at scales, that's the takeoff moment. Look at chess and Go. The early AI players were average, but once they learned, no human could come close. Memory and continual learning are the unlock that make an artificial brain act like ours. There are 8 billion humans, and some of them are brilliant, principled, and kind, and some are not. As AI companies race towards AGI, we're effectively creating a new kind of mind, a new kind of entity. And they're growing this thing, they're not making it. I just hope one thing. I hope it's kind, I hope it's generous and compassionate, and still has room for us. See you in the next one.